Hello everyone, a very good morning all of you. This is Chandrashekhar welcoming you all to the India's largest, the best and your favorite live learning platform, that is BYJU'S. And you guys are watching me live through the Concept Capsule series. And in this series, today's topic for discussion is the circuit diagram in mechanical engineering. So we will be talking about the basic circuit diagram which is going to be used in various subjects of mechanical engineering like fluid mechanics, heat transfer and so before I start, let me quickly introduce myself. Most of the students already know me. My name is Chandrashekhar. I am a mechanical engineering graduate from IIT Delhi and also cleared engineering services examination. I have worked in SAIL for a couple of years and from last 9+ years I am into teaching, guiding the students various examination like and ES. And I am quite comfortable in these many subjects, mechanical engineering, which are there on the. And also, you can always contact me through the mail ID which is there over the screen. And if you are not part of my Telegram group yet, it is my humble request to everyone to join me on the Telegram. My group is Mechanical by Chandrashekhar and the link. Right, so let us start our discussion, the basic circuit diagram. So as you all know, you must have studied about the basic circuit. In basic electrical circuit, there are three parameters. One is the current and another is the potential difference and the third one is the resistance. So we can call the potential difference to be V. And according to Ohm's law, in electrical circuit diagram, we can say the current flow is equal to potential difference divided by the electrical resistance, or we can say delta V is equal to I multiplied by R. What is the unit of resistance? The unit of resistance is Ohm, isn't it? So this is the basic circuit diagram. And for a single resistance, if there are multiple resistances which are arranged in series, then how to analyze the circuit? This is the current, I is the current. Let me call this as V1. This potential is V2 and the third potential. So according to series combination of resistance, we can say I will be equal to I1. The current flow across the first resistance is equal to the current flow across the second resistance equal to constant. Because at any point, the net flow must be 0. Sigma I net at any junction or at any point must be 0. So whatever the current entering should be equal to current leaving. This is the expression for current flow. And for potential difference, delta V, which is equal to V1 minus V3, can be written as V1 minus V2 plus V2 minus V3. The potential difference will get added. V1 minus V2, we can call it as delta V1, and V2 minus V3, let me call it delta V2. Delta V will be equal to, these two will get cancelled out. So we can say delta V will be equal to delta V1 plus delta V2. These are the two expressions when the resistances are connected in series, right? Further, we can also write delta V will be equal to I into R equivalent. According to Ohm's law, delta V1 can be written as I1 into R1 plus delta V2 can be written as I2 into R2 and so on. And as we all know, I will be equal to I1 is equal to I2. So these I terms will get cancelled out from left hand side and right hand side. So we can say R equivalent will be equal to, equivalent resistance will be equal to sum of individual resistances when they are connected in. All right, that is for series combination. Also, what we can say, I1 is equal to I2 for series combination. This is, let us say, I1. This is, let us say, I2. I1 will be equal to I2 because the resistances are connected in series. So what we can say, it is delta V1 upon R1 is equal to delta V2 upon R2, or we can say the ratio of delta V1 by delta V2 is nothing but the ratio of corresponding resistances. Delta V1, right? This is about the series combination. Now, if we talk about the parallel combination of resistances, if the resistances are connected in parallel, R1 and R2 are connected in parallel. Let me call this as I1 current. Let me call this as I2. The first expression says at any junction, net current flow at any junction, or at any node will be equal to 0. Is equal to that concept we can apply for the series combination also. This is the junction. This is the point where both the resistances are meeting. This is the junction for R1 and R2. I1 should be equal to I2 because the net current flow must be 0. What we can say, this is one of the junction. We can say I will be equal to I1 plus I2. Current entering is I, current leaving is I1 plus I2. Similarly, this is another junction. I1 and I2 should again be equal to I. There are multiple resistances. According to parallel competencies, the total current flowing in the circuit will be equal to sum of currents in individual across individual resistance. And also the second point says the energy is a point function. Energy or potential is a point function. What does that mean? If something is a point function, it cannot have two values at a particular point. Cannot have two values at a point. Values at, right? What does that mean? Try to understand here. If we call these points to be, this is, let us say, point A. Let me call this as point B. Let me call this as point, and this is, so what we can say, whatever, there are two junction X and Y. These are two junction. So we can say potential difference across the two junction. We can say Vx minus Vy can be written as Va minus Vb, or it can be written as V minus V. Isn't it? Vd minus Vc. So Vx minus Vy can be called as delta V. You can call it as delta V. You can say delta V is equal to delta V1. If we call it as delta V1, then is equal to delta V2. That is a parallel. And in another way, for the potential, what we can say? So look, before moving further, let me, I will be equal to I1 plus I2 plus so on. This was the expression. I can be written as delta V upon R equivalent will be equal to I1 is delta V1 upon R1 plus delta V2 upon R2 and so on. Cos delta V same as delta V1 is equal to delta V2. That is what we have already discussed for parallel combination, which will give 1 upon R equivalent will be 1 upon R1 plus so. That is how we can find out the equivalent resistance for the circuit diagram where the resistances are connected parallel. Also, as we know, delta V1 is equal to delta V2. What does that mean? If delta V1 is equal to delta V2, we can write from the Ohm's law. We can say it is I1 into R1 should be equal to I2 into R2. Isn't it? What is the ratio of I1 by I2? That is R2. The ratio of current I1, I2 will be equal to the ratio of reciprocal of the corresponding resistance. For parallel combination, what we can also say, for a closed loop, for a closed loop. What is a closed loop? For a closed loop. What is a closed loop? When the initial and final points are same. Come same. When the initial and final points become same and energy and potential is a point function, and when the initial and final points become same, so we can say sigma delta V for a closed loop must be equal to 0. Isn't it? Because the initial and final points are same, the energy will become same, the change in energy will become 0 for a closed loop. And when there are resistances in parallel, it will form a closed loop. Parallel resistance. Let me call this as A. Let me call this as point B. Let me call this as, let me call it point D. What we can say here is VA, or this, if we move in clockwise direction, VA minus VB plus VC minus VD must, VA minus VB plus VC minus VD is equal to 0, or we can say VA minus VB is equal to V. VA minus VB can be written as delta V1 and VD minus VD delta, according to the same concept. What we can say, delta V1 is equal to delta 2 when the resistances are connected in parallel. That is why for a it will form a closed loop, and for a closed loop the total energy or net energy becomes 0, net potential becomes 0. Similarly, for a junction or a node where two or more points meet, the net flow must be equal to, I hope it is clear to everyone. We can simplify the basic circuit diagram where there are 5 resistances arranged series and parallel. This is the current flow. You can say I1, this I2, call it as I3, I4, then we can call it as I. Right? Are you able to see it? This is I1, I2, I3, I4, and for a junction, I will be equal to I1 plus I2, isn't it? For a junction, net flow must be 0. It is another junction, I1 plus I2 is equal to I3. Then there is another junction is equal to I4 plus I5. That will become I again. That is one expression. And now to simplify this circuit diagram, R1 and R2 are arranged in parallel. R1 to 2 is R1 in R2 plus R2, because 1 upon R equivalent will be equal to 1 by R1 plus by R2. Here R equivalent can be written as R1 into R2 1 plus R2. Then R3 and R4 to 5 can be written as R4 into R5 on R plus R5. Now all the resistances are in series. All the resistances are in series. Here we can write, if you want to write I1, let me call it as V1. This V2 point represents V3, and this point represents is V. This is, you want to write I1. I1 will be equal to V1 minus V2 upon R1. You want to write I2, that is again V1 minus V2 upon R2. You want to write I3, that will be equal to V2 minus V3 on R3, and I4 will be equal to V3 minus V R4, and I5 will be minus V R5. Now we have developed the equivalent resistance for all the parallel resistance. R equivalent will be nothing but R1 plus R122 plus R3 R4. How we can is V1 V2 is V. This point represents V1 minus V4, that is delta V over all, right? I can also be written as V1 minus V upon R122 or V2 minus V3 upon R3 equal to V upon, or we can write it as V1 minus V4, that is V delta V over all upon R equivalent. That is how we can analyze the circuit diagram. Now, where do we use in fluid mechanics? Whenever we talk about the compound pipe system, series and parallel combination pipe. In that analysis, compound pipe system, the current will be replaced by the discharge, that is Q, unit is meter cube per second. Delta V, potential difference, can be replaced by the frictional head loss or delta PL, pressure drop or frictional head loss or frictional, and resistance will be replaced by the pipe. The analogous parameters are discharge, head loss, and the pipes. All the concepts which we have discussed can be used for analyzing the circuit diagram. We can draw the circuit diagram. In case of heat transfer, whenever we talk about the composite system involving combined modes of heat transfer, we use the circuit diagram. The current will be replaced by the heat flow rate, heat transfer rate, that is Q. The unit is joule per second or watt, and delta V will be replaced by delta T, thermal potential. The unit is degree Celsius or Kelvin, and resistance will be replaced by R, will be replaced by thermal resistance, that is called as thermal. The unit will be watt per Kelvin or watt per degree Celsius. And for radiation also, specifically that is for all the types of, all the modes of heat transfer, specifically for radiation also we use the circuit diagram, thermal radiation. When we talk about the thermal radiation, for thermal radiation exchange, so I will be replaced by Q1 to 2, net radiation heat exchange between exchange. The unit is watt. Then delta V will be replaced by either delta EB, that is EB1 minus EB2, or it can be replaced by delta J, that is J1 minus J2, radiosity. The unit is watt per meter. And resistance R will be replaced by either the space resistance, that is 1 upon A1 F122, or it can be replaced by the surface resistance, that is 1 minus epsilon upon epsilon. The unit is 1 by meter. This is how we can utilize the concept of circuit diagram in the understanding of various topics mechanical. I hope you have understood it. That is all for this. In Stenko materials also, when we talk about the compound bar, when we analyze the load and deflection curve analysis, load deflection, I will be replaced by the load, that is denoted by P, the unit is Newton. Delta V will be replaced by the linear deformation or linear deflection, that is delta L. The unit is meter, and the resistance can be replaced by the bar, the compound bar or composite bar. That is how we can analyze the situation or analyze the composite system, compound system by using the basic circuit diagram understanding. All right, so guys, that is all from my side for this session. We'll meet again in the next session for the concept capsule. Thank you guys. Thank you.